When it comes to searching for alien life, we're left with just two simple possibilities. It's either we are alone in this universe or we're not. But however the case may be, both are equally terrifying. Let me explain why. Firstly, the thought of being alone in this universe is quite unsettling. It would mean that Earth, with its vast diversity of life forms, is the only place where intelligent beings exist. The implications of this are profound. It would imply that the emergence of intelligent life is an exceedingly rare event, perhaps even a miraculous occurrence. It would also mean that the fate of the entire universe rests solely on our shoulders, as there would be no other civilizations to share in the exploration and understanding of the cosmos. On the other hand, the possibility of not being alone in the universe is equally terrifying, albeit for different reasons. If there are other intelligent civilizations out there, it raises the question of their intentions and capabilities. Are they benevolent, or do they pose a threat? Are they more advanced than us, or are we the more advanced species? And where exactly can we find them? I'm sure many of you here must have heard of the Fermi Paradox, but if you've not heard of it, let me break it down for you. It goes like this. What do you feel when you look up at the sky on a clear night and see an infinite number of stars shining like the brightest diamonds? Despite being breathtaking, this view is just of our closest neighborhood. Far beyond the reach of our best optical systems lie thousands of other galaxies, stars, and planets. There are as many galaxies in the universe as stars in our own Milky Way galaxy. You might be wondering where I'm going with all this. But let me finish. With all the greatness of planets, stars, and galaxies out there, where exactly is everybody? Or put another way, where are all the aliens? Are we really alone in the universe? Shouldn't there be other intelligent civilizations out there? The questions and answers that arise from all of this are called the Fermi Paradox. Here we are floating around on our little blue planet, thinking we're all that. We've got our advanced technology, sending out signals, launching probes, and dreaming of boldly going where no one has gone before. But guess what? We've found nothing outside our planet. When we hear about the Fermi Paradox, we always acknowledge Enrico Fermi as the one who started the argument because of his famous launch conversation, where he asked the question. But however, the Fermi Paradox was not initially posed by Enrico Fermi himself. The concept had been implicitly mentioned earlier by Konstantin Tsiolkovsky in an unpublished manuscript from 1933. Tsiolkovsky observed that some people denied the existence of intelligent beings on other planets in the universe. Their reasoning was based on two assumptions. If these beings existed, they would have visited Earth, and if advanced civilizations existed, they would have provided some evidence of their existence. While this lack of evidence was not seen as a paradox by many, it posed a paradox for Tsiolkovsky himself. He firmly believed in the existence of extraterrestrial life and the possibility of space travel. To reconcile this, Tsiolkovsky initially proposed what is now known as the zoo hypothesis. He speculated that higher beings, aware of mankind's unpreparedness, have chosen not to make contact with us at present. According to Tsiolkovsky, humanity needs to reach a certain level of advancement before being deemed ready for contact. Over the years, we've discovered more than 5,000 planets, and some of the planets we've discovered reside in the habitable zone of their parent star. But this is just a small number compared to the vastness of the cosmos. It's like trying to count the grains of sand on all the beaches of Earth with a single teaspoon. We're talking about an astronomical number of planets, each with its own unique features, potential for life, and cosmic real estate value. And let's not forget, the habitable zone is just one piece of the puzzle. There are countless other factors that could contribute to the existence of life on a planet. From atmospheric conditions to the presence of liquid water, the cosmic recipe for life is a complex one. In our Milky Way galaxy alone, according to experts, we have about 100 billion to 400 billion stars in our galaxy alone. This number might also be the same as the number of galaxies we have in the observable universe. That's a lot, right? I'm just getting started. Among all the stars in our galaxy, an interval between 5% to roughly 20% are like our own star, the Sun. meaning they have similar size, temperature, and luminosity as our own sun. If we are conservative and take the smallest quantities from both intervals, which is 100 billion stars, out of which 5% are sun-like, we arrive at the approximate number of sun-like stars in our galaxy, which is 5 billion stars. With all of that, let's now consider what percentage of these stars could be orbited by planets with similar conditions to the one we live in. A temperature similar to ours and the possibility to hold liquid water and potentially develop organic life. Some scientists say this number could go up to 50%, and for some, it's roughly 22%. Let's go with the smaller percentage. It then gives us about 1.1 billion sun-like stars that could be orbited by planets similar to planet Earth just within our galaxy. And then, from this point, there's not much science that needs to be done. All we can do is speculate, but let's continue. Okay, let's say out of these 1% develop life, and from that 1%, another 1% develop an intelligence similar to ours. This would result in more than 100,000 intelligent civilizations in our galaxy. Taking into account the efforts made by US humans in the last century to try to contact extraterrestrial life, or gather information from other intelligent civilizations, and the number of possible civilizations that probabilistic ally should be out there, shouldn't we be receiving signals? Why have we never received any kind of information or contacted other intelligent species? The universe as we know it is 13.8 billion years old now, right? And our star, the Earth, and possibly every structure in our solar system are roughly 4 to 5 billion years old. With this in mind, think for one moment about the differences between civilizations on planet Earth 500 years ago and our current civilization now. If we are so different from them in just half a thousand years, imagine how much more evolved an intelligent civilization that is 10 or 100 times our age would be. We might even be like monkeys to them, probably. Their technology and science would be completely incomprehensible. When we take a look at the Kardashev scale, it helps us differentiate civilizations depending on their technological and scientific capacities. It all began back in 1964, when the Soviet scientist Nikola Kardashev introduced a classification system that categorizes civilizations based on their technological advancement and energy utilization. This system, known as the Kardashev scale, encompasses various levels, starting from Type 1, denoting a civilization that has yet to fully harness the potential of its own planet, to Type 3, capable of harnessing the energy of an entire galaxy. So, basically, a Type 1 civilization should or would be able to control the energy of their planet, every single energy the planet has to offer, from earthquakes to different weather conditions, and then a Type 2 civilization should be able to control the energy of their entire parent star, which would require building some kind of Dyson sphere around the star. And a Type 3 would control all the stars in their galaxy. They'll be able to travel very fast, maybe as fast or even faster than the speed of light. So, where do we find ourselves on this scale? We occupy the position between 0 and 1, and it's going to take more than a century to reach a Type 1 civilization if we'll be able to maintain our race till then. Yeah, that's basically what the Kardashev scale is. But however, the scale goes up to Type 7 civilization. You can click the video in the description to watch it. But don't go anywhere yet, because we are not done. Carrying on with our previous speculation, let's imagine that 1% of intelligent life survived long enough to become a Type 3 civilization. That would mean there should be at least 1,000 Type 3 civilizations just in our galaxy alone. Also, civilizations of this sort wouldn't be too hard to detect. So, if I may ask, where is everybody? And now, what are the possible solutions to this paradox? One argues no super-intelligent beings exist, while the other suggests less concrete reasons for the lack of contact. The first is the theory of the Great Filter. This solution suggests that from the very beginning of life's emergence through the intricate stages of development, all the way up to achieving highly advanced civilizations on the Kardashev scale, there exists a significant obstacle that hinders the progress of life, making the existence of detectable extraterrestrial life extremely rare. The idea was first proposed in an online essay titled, "The Great Filter, Are We Almost Past It?" written by economist Robin Hanson. With no evidence of intelligent life in places other than the Earth, it appears that the process of starting with a star and ending with advanced, explosive, lasting life must be unlikely. This implies that at least one step in this process must be improbable. Hansen's list outlines a comprehensive evolutionary path comprising 9 crucial steps that could lead to the eventual colonization of the observable universe, which are the right star system, including organics and potentially habitable planets, reproductive molecules, simple prokaryotic single-cell life, complex eukaryotic single-cell life, sexual reproduction, multicell life, tool-using animals with intelligence, a civilization advancing toward the potential for a colonization explosion, which is where we are now, and colonization explosion. According to the Great Filter hypothesis, if this list were complete, at least one of these steps must be highly improbable. If the improbable step lies in the past, it suggests that humanity's chances of reaching step 9, interstellar colonization, are grim. Conversely, if the preceding steps are likely, then numerous civilizations should have progressed to a level akin to our own, yet we find no evidence of Step 9 being attained, as the Milky Way remains devoid of colonies. Hence, Step 9 may be the elusive and improbable milestone that hinders civilizations from flourishing. Potential obstacles preventing us from reaching Step 9 could include catastrophic events, underestimation of the impact of technological procrastination as our reliance on technology grows, or resource depletion rendering the step impossible due to the exhaustion of available resources, such as highly constrained energy sources. Therefore, by this line of reasoning, the discovery of multicellular life on Mars would be disheartening. Its existence would imply that steps 2 to 6 are relatively easy to achieve, thus directing attention to steps 1, 7, and 8, or perhaps an unknown step as the true stumbling block. Although steps 1 to 8 have indeed transpired on Earth, each one of them could still be considered unlikely. If the first 7 steps are necessary prerequisites for estimating probabilities based on our local environment, then an observer biased by the anthropic principle can glean nothing definitive about the general likelihood from its predetermined surrounding. I know, what I said might not make sense to you. Let me take another approach on this theory. Think of it like some kind of cosmic video game, where you have to pass through various levels to get to the final level. The Great Filter is like a level that all civilizations have to pass through, and it's really hard. Maybe it's a technological challenge, like developing interstellar travel or creating artificial intelligence. Or maybe it's a societal challenge, like avoiding catastrophic wars or solving problems like climate change. The idea is that many civilizations might not make it through the Great Filter. They might get stuck at some point, unable to progress any further. Maybe they never develop the technology they need, or maybe they destroy themselves in a catastrophic event before they get the chance. Our planet has successfully weathered numerous challenges in the form of mass extinction events, serving as filters for the evolution of life. Take, for instance, the Permian-Triassic extinction, also known as the Great Dying, which occurred approximately 250 million years ago. This cataclysmic event came close to obliterating life on Earth, devastating about 96% of marine species and 70% of land-dwelling organisms. Although the precise cause of the Great Dying remains a mystery, some scientists theorize that a combination of rising temperatures and declining oxygen levels played a role. However, it is crucial to note that these previous filters, manifested as natural extinction events, arose as part of our planet's and solar system's evolutionary processes. They were outcomes of volcanic eruptions, asteroid impacts, and other natural phenomena. Yet humanity finds itself potentially confronting a great filter of our own making. This filter could materialize in the form of imminent threats, such as climate change, nuclear warfare, or other catastrophes induced by human actions. Such dangers have the potential to impede our civilization's progress, preventing us from reaching the stage where communication with extraterrestrial life becomes possible. So the search for alien life is a bit like a cosmic game of hide and seek. We're looking for signs of other civilizations that have made it through the Great Filter, but we don't know how many have actually made it. Aliens might, for example, may choose to allow contact once we have passed certain technological, political, or ethical standards. They might withhold contact until humans force contact upon them, possibly by sending a spacecraft to the planets they inhabit. Alternatively, a reluctance to initiate contact could reflect a sensible desire to minimize risk. An alien society with advanced remote sensing technologies may conclude that direct contact with neighbors confers added risks to oneself without an added benefit. Everything I just said is what we know as the zoo hypothesis. The zoo hypothesis is a speculative explanation for the Fermi Paradox, which raises the question of why we have not yet detected any signs of advanced extraterrestrial civilizations, despite the high probability of their existence. The hypothesis suggests that there may be a deliberate effort by these civilizations to avoid making their presence known to us, essentially treating Earth like a zoo. Central to the zoo hypothesis is the application of the concept of hegemonic power to the Fermi Paradox. When I say hegemonic power, this is what I mean. It refers to the dominance and influence exerted by a civilization or entity over a significant portion of the galaxy. It implies that a particular civilization has achieved a level of control and authority that surpasses that of other civilizations or species within its sphere of influence. So, even if the first hegemonic civilization, which adopted a non-interventionist approach, has long vanished, its influence could endure in the form of passed-down traditions, or even in the form of an artificial superintelligence dedicated to upholding the principles of non-interference. In this scenario, the civilization that possesses hegemonic power does not necessarily have to be the very first one to arise, but rather the first to establish and spread a non-interventionist doctrine across a vast expanse of the galaxy. If a single civilization achieved hegemony in the distant past, it could establish an unbroken chain of cultural norms that promote non-interference in subsequent civilizations. In such a situation, the previously discussed concept of uniform motive becomes irrelevant. The primary challenge would then be how a galaxy-spanning civilization would effectively prevent intentional or unintentional communications from reaching Earth. Consider, for instance, the possibility that the oldest civilization still present in the Milky Way holds a time advantage of 100 million years over the next oldest civilization. In this case, it is conceivable that they could exert significant control, monitoring, influence, or isolation over the emergence of every subsequent civilization within their sphere of influence. This situation parallels what occurs on Earth within our own civilization on a daily basis, where individuals are born into pre-existing systems of familial associations, customs, traditions, and laws that were well established before their birth and over which they have little or no control. The zoo hypothesis, while speculative, provides a fascinating perspective on the Fermi Paradox and the absence of detectable extraterrestrial civilizations. It simply suggests that a highly advanced civilization may deliberately choose to observe and study developing civilizations like ours without directly interfering with them. This could be driven by a desire to allow natural evolution and development to take place, or out of a sense of non-interference ethics and the preservation of cosmic diversity own. But what about the idea that alien civilizations might deem communication too dangerous, both for humanity and for themselves? Drawing from historical encounters between vastly different civilizations on Earth, it is argued that such meetings have often resulted in disastrous outcomes for one side or the other. This pattern of adverse consequences could extend to interstellar contact as well. Even communication from a safe distance could pose risks of infection, whether through computer code or the transmission of dangerous ideas. Thus, cautious civilizations may actively conceal their presence not only from Earth but from all others, driven by a deep-seated fear of encountering unknown civilizations. It is plausible that the Fermi Paradox, or its equivalent in alien societies, serves as a compelling reason for civilizations to avoid contact with one another, even in the absence of other obstacles. From the perspective of any given civilization, the chances of being the first to initiate contact are highly unlikely. Therefore, it stands to reason that previous civilizations may have encountered fatal problems as a result of their first contact attempts, leading subsequent civilizations to deem such endeavors too perilous. Consequently, Each civilization may choose to remain silent and hidden due to the possibility that there exists a genuine, yet unknown rationale for other civilizations to do the same. In Liu Cixin's thought-provoking 2008 novel, The Dark Forest, the author offers a literary explanation for the Fermi Paradox. Within his narrative, multiple alien civilizations exist, but they adopt a policy of silence and paranoia, eliminating any emerging life forms that broadcast their existence too loudly. This defensive strategy arises from the recognition that any other intelligent species may eventually pose a future threat. As a result, Liu's fictional universe teems with hidden civilizations, akin to a dark forest concealing armed hunters, moving stealthily among the trees like elusive ghosts. This concept has become known as the dark forest theory. The dark forest theory portrays a universe where civilizations actively choose silence and concealment to ensure their own survival. It suggests that in a cosmos filled with potential adversaries, self-preservation becomes paramount, leading civilizations to remain hidden and avoid all forms of communication. Within this paradigm, the universe resembles a vast forest, where each civilization fears the presence of others and takes extreme measures to protect itself. The result is a hauntingly quiet cosmos, perpetually on guard against potential threats. This notion of civilizations shrouded in secrecy and trepidation offers a captivating explanation for the Fermi Paradox. It prompts us to consider the possibility that the universe is teeming with advanced civilizations, but their inherent caution and fear of the unknown drive them to maintain an impenetrable veil of silence. The dark forest theory invites contemplation on the existential risks and dilemmas that intelligent civilizations may face as they navigate the uncharted territories of the cosmos while grappling with their own survival. One hypothesis suggests that alien technology could be so advanced that it seamlessly blends into the fabric of nature, rendering it virtually indistinguishable from the natural world. Such highly advanced civilizations may have harnessed technology that harmonizes with their environment, making it difficult for us to detect their presence. Another captivating idea is that alien life might exist in forms that are beyond our current comprehension. We tend to envision life based on our own experiences and the familiar building blocks of biology. However, what if alien beings exist as energy-based entities or thrive in environments radically different from our own? Exploring these uncharted possibilities could open up new avenues for discovering extraterrestrial life. Moreover, it's conceivable that intelligent life exists in dimensions or parallel universes beyond our current understanding. These realms might be inaccessible to us with our limited perception and scientific capabilities. While we explore the physical universe, there could be other dimensions where life flourishes, waiting for the right circumstances to intersect with our own reality. Perhaps intelligent life is patiently waiting for us to reach a specific level of technological advancement before initiating contact. This notion aligns with the idea that civilizations may adhere to a non-interference policy until certain criteria are met. It suggests that the universe may be teeming with intelligent life, but until we achieve a certain level of maturity and progress, contact remains elusive. Another possibility is that we have simply not searched in the right places yet. The vastness of the universe presents an immense challenge, and our search for extraterrestrial life has primarily focused on environments similar to Earth. However, alien life may thrive in conditions and locations that differ drastically from our own. Expanding our search parameters and exploring unexplored realms could yield exciting discoveries. Furthermore, the enormity of space itself poses a potential obstacle to contact. Even if intelligent life exists, the vast distances between star systems make direct communication or physical interaction immensely challenging. The cosmic expanse may have isolated civilizations from one another, resulting in a profound silence across the cosmos. Additionally, it is plausible that intelligent life exists, but is simply not interested in making contact with us. Their motivations, priorities, or communication methods might differ significantly from ours, rendering our attempts to establish contact fruitless. This perspective reminds us that the universe is vast and diverse, accommodating a myriad of possibilities regarding the behavior and intentions of extraterrestrial civilizations. Lastly, The chilling notion of being the only life form in the universe cannot be discounted. While it may seem disheartening, it also emphasizes the immense responsibility we have to safeguard and advance life. Civilization and consciousness are like fragile candle lights flickering in the darkness. We must recognize the preciousness of our existence and ensure that this delicate flame doesn't go out. The vastness of the universe underscores the significance of nurturing and protecting life, both on our planet and potentially beyond. As we ponder the various possibilities and contemplate our place in the universe, it is essential to approach the search for extraterrestrial life with curiosity, open-mindedness, and humility. The quest to uncover the mysteries of the cosmos continues to unfold, pushing the boundaries of our knowledge and revealing new wonders. Well, that's basically it. But you guys need to understand that the search for intelligent life extends far beyond the realm of scientific exploration. It taps into our innate longing to connect with something greater than ourselves. Discovering an alien civilization would transcend the mere confirmation that we are not alone in the universe. It would ignite a transformative shift, charting a new course of evolution for our species. The prospect of encountering an advanced extraterrestrial civilization is profound. It would offer a glimpse into alternative paths of development, new ways of thinking, and unimaginable advancements. The exchange of knowledge and ideas with an alien species could propel our own technological, cultural, and societal progress to unprecedented heights. Moreover, the discovery of intelligent life beyond Earth would reshape our understanding of our place in the cosmos. It would challenge our notions of uniqueness and insignificance, fostering a sense of unity and interconnectedness on a cosmic scale. The realization that life exists elsewhere would serve as a testament to the remarkable diversity and resilience of the universe. As we continue to search the depths of space, driven by an insatiable curiosity, we must remember that the quest for intelligent life is not merely an intellectual pursuit. It represents a profound yearning to establish a connection with beings who may possess knowledge, wisdom, and perspectives beyond our own. It stirs our imagination and ignites a spark of hope that we are part of a larger cosmic tapestry. Remember when I mentioned about the different levels of civilizations? Civilizations that could go up to Type 7? Yeah, click the video up on your screen to watch it. Thanks for watching, and I'll see you in the next one.